Alright guys, welcome to this page of the notes, and what I've got for you here is just a little bit more practice. Hopefully what you're doing at this point is you feel comfortable with what we've done so far. You've gone ahead, you've already tried these problems on your own, and you're just now coming back, check and see what I got as an answer. So let's go ahead and figure out what I do get. What I have for you, if C, which is at the point 2, -1, so xy, is the midpoint. Okay, so here's what I've done. I've given you the midpoint, which means that this is not x1, y1 or x2, y2. This is actually your midpoint, x, y, right? If it's the midpoint of the line segment AB and A is located at the origin, I want you to find the coordinates of B. Guys, please draw yourself a picture. Please, 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 please. I have A, B. I tell you that C is the midpoint. There's C. And it is the midpoint. And it is at 2, -1. I also tell you that point A is at the origin, which is 0, 0. I've given you the midpoint and one of the endpoints. I'm asking you to find the other endpoint. This is the midpoint formula, but just doing it in a slightly different order. Please remember that the midpoint formula is this. Midpoint is equal to x2 plus x1 over 2, comma, y2 plus y1 all over 2. Okay. Here's what I've done. This gets you the x coordinate, which I've already given you. This gives you the y coordinate for the midpoint, which I've already given you. So here's what you're going to do. You're going to take this guy and set it equal to the x coordinate of the midpoint. So 2 is equal to x2 plus x1 all over 2. And you're going to take this guy, which gets you the y coordinate of the midpoint, but you already know that, and set them equal. So -1 is equal to y2 plus y1 over 2. Now, you know something else. You know one of the endpoints. Either x1, y1, or you could call this x2, y2. Doesn't matter which one. So I will call it x1, y1, and I will plug in zeros for x1 and y1. Since that point is at the origin, right? That's my x1, that's my y1. Plug those guys in. Now, this is a very simple algebra problem. x2 plus 0 is just x2. So this means, I'm going to squeeze down here a little bit. So 2 is equal to x2 over 2. And this one, y2 plus 0 is just y2. So -1 is equal to y2 over 2. Okay, well, how do I get the x2 and the y2 by itself? Since I'm dividing by 2, algebra says multiply that guy to the other side. 2 times 2, 4 is x2. Multiply the 2 to the other side, which would be a -2, is equal to y2. And so I have the point 4 minus 2, which means that this point right here, this point B, is at 4 minus 2. Right? So even if I give you the midpoint and one of the endpoints, you can solve for the other endpoint by just simply using the midpoint formula. It's just instead of plugging everything in and finding your x and y value for the midpoint, I've already given them to you. So you just set up a couple of little simple algebra problems and solve for the variable that you don't know. Yes, I will ask you to do that. That's something that you should be able to do. Okay, let's go ahead and do another one. Let me go ahead and erase this. Hopefully you've got that written down. This was our answer, therefore. That one, that is point B. In fact, I should have written that. That's point B. The end point B is at 4 minus 2. All right, so we'll go ahead and erase that stuff so I have space to do my next one. All right, here we go. I have E. E is the midpoint. Awesome. E is the midpoint of DF. So let's actually go ahead. Draw your picture first. I have D. I have F. And E will be the midpoint of that line segment. So there is E. What that tells me, go ahead and use the proper geometry nomenclature or notation. Those guys are congruent. I put those little dashes in there. You know that they have the same magnitude and the same shape. They're both line segments and they're equal to each other. Same shape, both line segments, and same magnitude. They're both equal, same distance. Congruency, both magnitude and shape. Both line segments and they have the same magnitude, all right? So those are congruent line segments. Here's what I tell you. I tell you that DE is 4x minus 1. So let's go ahead and put that in there. This is 4x minus 1. I tell you that EF, okay, so EF is 2x plus 9. Okay, I want you to find the value of x and find the measure of DF. Hey guys, this is segment addition postulate, right? I've given you two segments. I want you to find the length of the full segment. So here we go. Segment addition postulate would tell you that DE plus EF is equal to DF. Plug and chug, right? Oh, I apologize. Hold up one second. I'm sorry. Hold up one second. I'm getting ahead of myself. I asked you to solve for x first. All right, so here's what we're doing. I told you that E is the midpoint, which means that these two segments are congruent, right? Knowing that the midpoint is the center, meaning that those two segments are equal to each other. Again, the algebra problem that you would then set up, knowing that midpoint gives you two equal segments, you can set these guys equal to each other. So the first thing I'm going to do is set 4x minus 1 equal to 2x plus 9, right? Why? Well, because I know that this segment and this segment have to be equal to each other. They have to be congruent. How do I know they have to be congruent? I tell you that E is the midpoint. I'm able to set up this problem because I know something about the definition of midpoint. Do you see where the geometry is coming in here? Knowing a definition, a postulate, or a theorem allows you to take what you're given and set up something that you can then use to get your answer, all right? All I told you was that E was the midpoint. You need to then use that to set up your problem, and that's where the geometry is coming in. In algebra, I would have just given you this. Maybe not, but probably I would have just given you this. Here in geometry, you've got to use those definitions, those theorems, those postulates to help you set up the problem that will allow you to get to the solution. Okay, so here we go. Let's subtract the 2x to this side, which will leave me with 2x. I'll add the 1 to this side, which will give me 10, which means x is equal to 5. Now, that is one of my answers because I did ask you to find the value of x. But now I ask you to find df. Now there's a couple of ways that you could do this. And I'll leave it up to you. I'll show you which way I'm going to do it, but I'll leave it up to you. You could plug x in, find this magnitude. You could plug x in, find this magnitude, right? And then add them together. But since DE and EF are the same, they're congruent, what you could do is just take one of the segments and multiply it by 2. If you double it, you would get the full length because they're congruent. They're the same. If I have two segments that are exactly the same length and I want to know the entire length, you could add both of the segments together, or you could take just one of the segments, multiply it by 2, and you would get the same thing. I'm going to do that one. So I know that df, which is what I'm looking for, is equal to, and again, it doesn't matter which one, they're congruent. Pick whichever one you want to. I think I like this one because I like addition a little bit better, and it's easier to multiply by 2 than it is to multiply by 4. Not that 4 is difficult, but I will do 2 times the segment EF. Right? Just multiply EF by 2, and I get the whole thing. Now you certainly could add them together. You could, but let's try this. So df is equal to 2 times 2x plus 9. That is segment EF. I know that x is 5, so I'll plug that in. 2 times 2 times 5 plus 9. And don't fat finger something on your calculator. df is equal to 2 times 5 is 10. 10 plus 9 would be 19. And 38, 19 times 2, so here, let me write it out, that's 2 times 19, I apologize, brain fart there. 2 times the 19, so then DF is equal to 38. So there we go. I have found both. I should put it in green. I asked you to find 2 things, and you found both of those things. You found both the value of x and the entire thing using the segment addition postulate. Segment addition postulate. And this one up here, we use the midpoint. You actually also use the midpoint in here as well. You had to know 2 things. You needed to know something about the definition of midpoint and the segment addition postulate in order to arrive at your solution for this problem. And hopefully you're beginning to see how this geometry is going to work, all right? As we go through this course, we will get more and more and more postulates and theorems and definitions, and you'll be using all of these things to help you kind of piece together the way to arrive at your solution. And that's what makes geometry a little bit different than algebra. Slide this guy on up. I just talk about these for a second. There really aren't any problems here. Here's what we've got. A segment bisector. The definition is really important. Hopefully you can read it. Hopefully you've got the notes in front of you there. Let me highlight it for you. Here's what it says. Any segment, line, or plane. Segment bisector. Any segment, line, or plane that intersects a line segment at its midpoint. So, bisector means that you're dividing something by 2 into 2 equal parts. Segment bisector, you're dividing something into 2 equal parts. Guys, this can go a couple of different ways. I got a few examples for you here, okay? First, I have a line. M could be my midpoint, meaning it has divided AC into 2 congruent parts, A, B, and BC, right? B is my segment bisector. It's my midpoint. It divides it directly in half. That's a point. I could divide a segment using a line. I have the segment WY. If this line TS runs through the midpoint, if X is the midpoint, instead of telling you that X is the midpoint, I will simply say line TS is a segment bisector of the line WY. What that tells you, that this line TS divides WY, the line WY, into 2 congruent parts, WX and XY. They're congruent, and you can see that from the 2 hash marks. This line is not straight. It has a slope to it. Doesn't have to. I could make it a vertical line, where they intersect is a right angle. Not a right angle, still a segment bisector. Right angle, still a segment bisector. Line JP, right? Line JP, 2 points on that line, is a segment bisector of the line HK. Right? All that means is it splits it right in half. HP is congruent to PK, right? So bisector, when you have a segment bisector, it will divide that segment right in half. You could also do it for a plane. The plane, right? This plane intersects my line, right at its midpoint, right at the midpoint. This one is at a slant. This one is perpendicular, meaning that the line and the plane make a right angle to each other. I could put that little right angle. Oh, sorry, that's my highlighter. Hold up. Let me get my pen. And put that little right angle symbol in there, showing you that, right, I've got that plane and my line is coming down through the plane, right? And so my plane bisects my line right in the middle. It gives me 2 congruent segments, top and bottom, but they're at 90 degrees to each other. I could put that little 90-degree symbol in there, as opposed to this one, right, where I have my plane, but my line is going through at an angle. So they're not at 90 degrees to each other, right? But I still have the same congruent segment on above the plane as I have below the plane. So the plane is the segment bisector of this line. All right, so segment bisector, you're dividing something right through the midpoint. You're getting 2 congruent segments. So what we'll do is head on over to the next page of the notes. We'll try a couple of problems dealing with segment bisectors. I'll meet you guys there.